Hi students, in this session today we are going to learn about laws of chemical combination from the chapter Some Basic Concepts of Chemistry. Okay students, in this topic we shall be learning about law of conservation of mass. This is the first law, and second one is law of constant composition, and third one is law of multiple proportions, and fourth one is law of reciprocal proportions, and last one is law of combination, law of combining volumes, and this is also called as Gay-Lussac's law of gaseous volumes. Okay students, in 1-1 session we shall be learning about 1-1 topic. Okay, why? Because just I'm going to give you a clear cut idea and some solved examples, also just some problems also based on these laws of chemical combination. Okay, then students, each one we shall be discussing in 1-1 class. Today in this session we shall be starting with this first one, law of conservation of mass, and including with the law of chemical combination completely, the introduction part and the first one. Okay, let's get started. Actually, one of the most important aspects of the subject of chemistry is the study of chemical reactions. About chemical reactions, students, you know very well, in that chemical reaction particularly the participation of reactants and the formation of products takes place. That is about the chemical reaction, you know very well. So here is the example, just I have written A and B, these are the reactants. Reactants undergoes a change, it leads to form products, that thing you know very well. And here C and D are the products. Here there must be a formation of some intermediates, and by the adding of some reagents also takes place. Reagents. Okay, and these chemical reactions takes place according to certain laws. These are only called law of chemical combination. Okay, these are 5 about law of chemical combination. The first 4 laws, this here you can see, these first 4 laws deal with the mass of just mass relation, basing upon the mass of the products and the mass of the reactants. Okay, whereas the fifth law, law of combining volumes, deals with the volumes of the reacting gases. Let us now discuss. First one is law of conservation of mass with one activity. Before going to do that, what is chemical combination, you have to know, students. Okay, chemical combination, for suppose just combination of some elements leads to give some compounds, those are only products, that thing you know. And basic principles obeyed by interacting atoms and molecules, interactions, these two interactions that can include many different combinations that happened in many different ways. Let's discuss now one by one. The first one, law of conservation of mass. This law, which deals with the masses of the reactants and products of a chemical reaction. You know students, in a chemical reaction there must be a presence of reactants and as well as products. Okay, without these two there is no chemical reaction. And the products of a chemical reaction, as I told you, or a physical change. This was just about physical change also you are going to study in this laws of conservation of mass. And this law is this was studied by the great French chemist. Here is the scientist name you have to remember, Antoine Lavoisier. Okay, in the year of 1789, the scientist name is very very important, you have to remember this. Let's see the definition of this law. In all physical and chemical changes, the total mass, this is only law of conservation of mass. Okay, here the total mass of the reactants is equal to that of products. For suppose here, basing upon this, you can conclude that the mass of the reactants completely equal to the mass of the products. Okay, this is only the conclusion of law of conservation of mass. Thus, according to this law, there is no increase and decrease in the total mass of the matter during a chemical or physical change. In other words, matter definition, you know students, anything that occupies some space and it has mass is known as matter. Okay, matter can neither be created nor destroyed. Okay, that means we cannot create matter and we can't destroy the matter. Hence, this law is also called the law of indestructibility of matter. Okay, this law of conservation of mass, this law is also called as law of indestructibility of matter. Now, some experiments illustrate the truth of this law. Here you can see, first suppose a law of conservation of mass. Here, two experiments. The first one is when matter undergoes a physical change. Matter undergoes a physical change. And second one is when matter undergoes a chemical change. In this first law of conservation of mass, you are going to study about two cases. The first one is matter undergoes a physical change and the second one is matter undergoes a chemical change. Again, in this second type, you shall study about precipitation reaction and decomposition of mercuric oxide. Here the decomposition reaction also you are going to study. In this second type, matter undergoes a chemical change. Okay students, now we shall discuss about matter undergoes a physical change. When matter undergoes a physical change, a piece of ice, here is the solid form of water we can take as a piece of ice, is taken in a small conical flask. Conical flask structure, you know, just like this. In this small conical flask, you have to take solid water, that is only ice cube, and it is well corked. Then you can place here itself a rubber cork. This is rubber cork. Okay, and you can wait. After weighed, the flask is now heated gently to melt the ice solid into liquid. Now students, the flask is again weighed. Here also you can check the weight of this conical flask. Now it is found that there is no change in the weight, though the physical change has taken place. Here already physical change takes place after melting of this solid substance. Okay, after applying some heat to this, so it will become into liquid. The weight is same. The weight of the solid substance, that means the weight of the ice cube and the weight of the liquid substance is same. You should observe this. Okay, this is about the matter undergoes a physical change. Now if you see the second example, when matter undergoes a chemical change, some types I told you, that is a precipitation reaction, and the second one is decomposition of mercuric oxide. Let us see about those. In this first type of reaction, here you have to know about the new word has come here, Landolt. So Landolt tube. Okay, here you can see two U-shaped. Here, these are the U-shaped tubes which are having. Here is the solution what you are going to take, and here also the solution, and which fixed with a tight rubber corks. So what is the use of these rubber corks, students? To avoid the escaping of the fumes from these tubes. First one, if you take this Landolt tube, and here is the sodium chloride solution, and here in the second tube silver nitrate AgNO3 solution we can take here. So Landolt took the solutions of sodium chloride and silver nitrate separately in two limbs of the Landolt tube. These two are called limbs. So this is entirely called as Landolt tube. Okay. The limbs were then corked and the tube was weighed. Initially you have to check the weight of the Landaulet tube before the reaction, and thereafter the tube was tilted to allow the two solutions to mix. You can reverse the tube. Then students, these two solutions are going to mix here. Then what will happen? NaCl plus AgNO3. These two substances are going to mix. Okay, then as a result of the chemical reaction, a crude white precipitate of silver chloride, that should be AgCl, silver chloride, and including with these sodium nitrate NaNO3 also will be formed. Here let's see the clear cut equation of this chemical reaction. This is the chemical reaction when NaCl mixing with silver nitrate. Okay students, here is the NaCl is in aqueous medium and silver nitrate also is in aqueous medium, and this is a solid substance. Why? Because this is only precipitate. Curdy white precipitate, here white color. Now NaNO3, sodium nitrate also is in aqueous medium. After the reaction, the tube was again weighed. It was found that weight practically remained unchanged. So you can observe that same weight of the reactants and the same weight of the products. Here students, you can conclude that there is no change in the weight of the reactants and the weight of the products also. This is the example of what we discussed now, precipitation reaction. Now students, we shall discuss about decomposition of mercuric oxide. In this type of reaction, 100 grams of mercuric oxide is HgO, you have to take as 100 grams, okay, which is in solid state. So here are the physical state we have to mention. Okay students, mercuric oxide when heated in a closed tube, decomposed to produce here Hg, mercury, which is in liquid state, plus half O2, which is in gaseous state. This is the entire chemical reaction. Here students, 92.6 grams of mercury and 7.4 grams of oxygen. Thus, during the above decomposition reaction, matter neither gained nor lost. Okay, the mass and energy are interconvertible, but the total sum of the mass and energy during any physical or any chemical change remains constant. We have to prove that. Here is the weight of mercuric oxide and weight of the mercury and oxygen separately also same. These are the reactants and these are the products according to law of conservation of mass. Now students, let's see about law of conservation of mass and energy also. In a number of reactions, especially the nuclear reactions, if you take the example of nuclear reactions, here the mass of the products is found to be slightly less than the mass of the reactants. The question arises, where is this mass lost? According to Einstein, this mass is converted into energy according to the equation E is equal to mc square. This is the most important Einstein's proposed equation, where m is the mass lost and c is the velocity of light. Hence, the law of conservation of mass has been modified. Now it is known as law of conservation of mass and energy. Okay students, here you can say the definition of this law of conservation of mass and energy. The mass and energy are interconvertible, but total sum of the mass and energy during any physical change and chemical change remains constant. We have to conclude that. Now let's see some problems based on the law of conservation of mass. Here is the first example. 4.90 grams of KClO3 when heated produced 1.92 grams of oxygen and residue KCl left behind weighs 2.96. Show these results illustrate the law of conservation of mass. This is the question. Okay students, what is meant by residue? Here is the new word. Residue means an insoluble substance. After completion of the chemical reaction in the test tube, any solid substance remains, that is known as residue. That is only insoluble substance, we can say that. Now students, mass of KClO3, what they have given, the mass of KClO3 taken is 4.90 grams. They have given in the question itself. Okay, now total mass of the products. Total mass of the products means, can say that total mass is KCl plus O2. Here is the chemical equation. You have to write like this. Here KClO3, when it is heated, then KCl is formed as residue and O2 is liberated. This is the net reaction. Now the total mass of the products is KCl. Weight of this KCl, what they have given here, KCl weight means 2.96. They have given in the question. And what about oxygen? Oxygen weight 1.92. They have given is equal to 4.88 grams. Now this weight KClO3 they have given in the question itself 4.90 grams. Now students, the total difference between the mass of the reactants and the total mass of the products, if you do the calculation, 4.90 minus 4.88. Now 0.2 grams, this is the difference between the mass of the reactants and the products. The small difference may be due to the experimental error. So, does the laws of conservation of mass holds good within the experimental errors also? Okay students, this is about the first example. Now let's see the second example now. What mass of silver nitrate will react with 5.85 grams of sodium chloride to produce 14.35 grams of silver chloride and 8.5 grams of sodium nitrate, if the law of conservation of mass is true? Okay, in the question what they have given, just we shall represent that in a chemical equation. When silver nitrate reacting with NaCl, sodium chloride, now silver chloride will be formed including with sodium nitrate, NaNO3. So this is the chemical equation. Now we shall represent the weights what they have given in the question. NaCl weight is 5.85. Here is the 5.85 grams and AgCl weight is 14.35. 14.35 grams of AgCl and 8.5 grams of sodium nitrate. Okay, and what mass of AgNO3? We have to calculate the weight of this silver nitrate. This you can say x grams. Now students, we can calculate that. Here x plus 5.85 grams is equal to 14.35 grams plus 8.5 grams. Okay students, now you can write like this. X is equal to, if you add these two, you should get 22.85. Now x is equal to this 22.85 minus 5.85. Now the x value is 17.0 grams. So this is the total weight of silver nitrate. Okay, this is the answer of second example. Now we shall go for next example. When 4.2 grams of NaHCO3, this is sodium bicarbonate or sodium hydrogen carbonate, is added to a solution of acetic acid. Here is the formula of acetic acid is CH3COOH. Weighing 10.0 grams, it is observed that 2.2 grams of CO2 is released into atmosphere. The residue left behind is found to weigh 12.0 grams. Show that these observations are in agreement with the law of conservation of mass or not. We shall discuss now the solution of this. For suppose the starting one, when 4.2 grams of 4.2 grams of NaHCO3, sodium bicarbonate. It is going to treat with acetic acid. Acetic acid formula CH3COOH. Now weights also, just I shall represent now. Here is the 4.2 grams and here 10.0 grams. Now in products, sodium acetate, according to these reactants, CH3COONA plus H2O plus CO2 gas will be liberated. Okay, here is the residue weight 12.0, residue 12.0 grams. Here is the residue sodium acetate. Now H2O and formed CO2 is 2.2 grams. Okay, now the total mass of the reactants, if you do total mass of the reactants, 4.2 plus 10.0 grams, you should get 4.2 grams. This is the weight of the reactants. Now if you do the calculation of total mass of the products, 12.0 plus 2.2, now also you should get 4.2 grams. Now students, you can say that the mass of the reactants is equal to the mass of the products. Hence the law of conservation of mass proved. Okay students, this is about our today's session, law of conservation of mass from the subtopic laws of chemical combination. Okay, here we have the mind map. So in this law of conservation of mass, two types we have discussed. In second type, matter undergoes a chemical change, the precipitation reaction and decomposition of mercuric oxide also we have discussed in this session, and some problems based on law of conservation of mass. How can we decide that reaction is law of conservation of mass is applicable to that reaction or not, also I have explained to you. Okay students, if you understand this class, you can subscribe to this channel for my further updates. Thank you so much. Thanks for watching.